In this video, we are going to look at 2D problems in trigonometry. So we're just going to go through a few examples. For example 1, we have in triangle ABD, BD is perpendicular to AC and BAC is equal to 35 degrees. Then CAD is equal to 27 degrees and AD is 5,5 meters. So calculate the length of AB. Now what we're going to do, we see that AB lies over here, and we are currently working in right angle triangles and using our trig ratios. Now with this triangle, we do not have enough information yet to actually calculate AB. So we are going to move over to this triangle first and then find a side that also belongs to triangle ABC so that we have then enough information to find AB. So the first thing I'm going to do is going to find side AC, and using the trig ratios outside from this angle, side AC is your adjacent side and this is the hypotenuse side. So the trig ratio that applies to adjacent and hypotenuse is cos. So I'm going to say that cos of 27 degrees is equal to adjacent over hypotenuse. So that's AC over 5,5. And then I simply solve for AC. So AC is equal to 5,5 multiplied by cos of 27 degrees. So we're simply just going to put that into the calculator. So we have 5.5 times by cos of 27, and that's 4,9. And that's in meters. So 4,9 over here. All right, so now I can find AB. So from this angle, we have adjacent and hypotenuse again. And then I'm going to say that, okay, so that's cos. So cos of 35 degrees is equal to adjacent over hypotenuse. So that's 4,9 over AB. And then when I solve for AB, AB goes up and cos 35 comes down. So AB is equal to 4,9 over cos of 35 degrees. That then gives me, if I put that into the calculator, 4,9 times by cos 35. Okay, so that's 4,01. Oh, sorry, not times, it's over. 4,9 over cos 35. Okay, so that's 5,98 to 2 decimal places, and remember your units, it is in meters. Right, now for example 2, in triangle ADC, DAC is 42 degrees, DBC is 61 degrees, and DC, the length of DC is 35 centimeters. Calculate the length of AB. Now the length we want to find is over here. And in this triangle ADB, we can't actually apply any trig ratios because it's not a right angle triangle. So the right angle triangles that we do have is DBC and the big one, DAC. And how we're going to approach this problem is first to find this length. If I have the length of AC and I have the length of BC, I can actually then calculate AB because I just subtract the small one from the long one. Now, first of all, I can work in the small triangle to find BC and then the big triangle to find AC. So going ahead with that, if we work out of the angle of 61 for the smaller triangle, we have the side here is opposite, and the side we are interested to find is BC, and that's the adjacent side. So opposite and adjacent is tan. So I'm going to say tan of 61 degrees is equal to opposite over adjacent. So it's 35 over BC. Then we simply solve for BC. BC is equal to 35 over tan of 61. And we type that in. 35 over tan 61. So that's 19,4, and that's in centimeters. All right, so this is then 19,4. Now to find AC, we use the big triangle, and from this angle over here, we yet again have opposite and adjacent. So once again, we're just going to use ton. Ton of 42 degrees is equal to opposite, which is 35, over adjacent, which is AC. Solve for AC, and we get 35 over ton of 42. Type it in. And that gives us 38,87. Okay, so now if this long side over here is 38,87, then to find AB, I'm simply going to take AC and subtract the 19,4. So AB is equal to 38,87 minus 19,4, and that would give us 38.87 minus 19.4 is equal to 19,47, and units is in centimeters. Okay, so example 3. So we have EF is perpendicular to FH. Then we have FG is perpendicular to GH. We have HEF equal to 48 degrees, HFG equal to 32 degrees, and HG equal to 10 meters. Calculate the length of EF. Alright, so this one is very much like the first example, where we have two triangles, both are right angle triangles. We want to find a side in this triangle, but we need another side in that triangle before we can find it. So we use this triangle first to find HF and then to find EF. So if I want to find HF from the 32 degree angle, what I have is 10. What I want is HF. So what I have is opposite. What I want is hypotenuse. So opposite and hypotenuse is sine. So sine of 32 degrees is equal to opposite over hypotenuse. So 10 over HF. And then solve for HF. So HF is equal to 10 over sine of 32 degrees. We simply work that out. So that is equal to 18,87. Okay, so here we have 18,87, and then we want to find EF. So from the 48 degree angle, we have opposite over adjacent, and opposite over adjacent is ton. So ton of 48 degrees is equal to, opposite is 18,87, and adjacent is EF. So solve for EF, and we have 18,87 over ton of 48 degrees, and that would then give us ton 48, 16,99. So this is 16,99, and the units is in meters. Then we are done.